Hi everyone, today a video on the amount of substance topic, looking specifically at moles in solution. So we know that a solution consists of a solvent with a solute, a solid, dissolved in it. And the concentration of that solution tells us how much solute is present in a known volume of solution. If a solution is very concentrated, it has a lot of solute dissolved in it. If the solution is very dilute, not very concentrated, then it has very little solute dissolved in it. And so concentrations, or sometimes called the molarity, are measured in moles per decimeter cubed. And 1 mole per decimeter cubed means that there is 1 mole of solute dissolved up in a cubic decimeter of solution. And we can write a mathematical equation for this, where we say that the concentration is the number of moles, units of mole, divided by the volume, which is the units of decimeter cubed. So we can say that C, the concentration, is equal to M, the moles, divided by the volume, V. So we can also rearrange that equation to give us that the number of moles, when we're talking about a solution, is the concentration times the volume. So this is slightly different from the moles equation in our previous video of this series, where we said that if we have a solid, the number of moles that we can use is the mass divided by the MR, the mass divided by the molecular mass. Here in solution, it is the concentration times the volume that gives us the number of moles. But we have to be careful with our units. Concentration, remember, is given in moles per decimeter cubed. Volume is most likely going to be given to you in centimeters cubed. Think about whenever you've actually measured out a volume of a liquid, it's normally in milliliters or centimeters cubed. You rarely do it in decimeters cubed. And we can't times together a centimeters cubed volume and a mole per decimeter cubed concentration. Those units don't match. So we have to convert our volumes into decimeters cubed from centimeters cubed. And so the way to do this is a couple of ways to remember. The first is to remember that 1 litre is the same as 1 decimeter cubed, and that 1 milliliter is the same as 1 centimeter cubed. And so therefore, the difference between a litre and a milliliter is timesing by 1,000, or dividing by 1,000. It's 1,000 difference. And so to convert from decimeters into centimeters cubed, we times by 1,000. To convert from centimeters cubed to decimeters cubed, we divide by 1,000. The other way to remember it, and the way that I personally remember it, is to remember that 1 meter is the same as 10 decimeters and the same as 100 centimeters. And now if I cube all of this, 1 meter cubed is equal to 1,000 decimeters cubed, that's 10 cubed, and it's equal to 1 million centimeters cubed, 100 cubed. So to go from decimeters cubed to centimeters cubed is times by 1,000. You can also think about it of going from decimeters to centimeters is timesing by 10, so decimeters cubed to centimeters cubed is timesing by 1,000. And then conversely, from centimeters cubed to decimeters cubed, we divide by 1,000. So it's really important that you make sure that you're comfortable converting these units, and that you always convert centimeters cubed into decimeters cubed if you're given it as centimeters cubed for your volume. And we can write therefore a kind of more general equation that normally N equals C times V divided by 1,000. And the dividing by 1,000 is to kind of automatically convert our centimeters cubed volume into a decimeters cubed. So an example of a calculation: what volume of HCl that has a concentration of 1.5 moles per decimeter cubed would need to be added to a 25 centimeter cubed solution of sodium carbonate of 0.4 mole per decimeter cubed concentration to give a neutral solution? Now, this idea of being a neutral solution means that we've added enough acid to neutralize all the base. So the way to go about it, and the way to go about all of these kind of mathematical questions, even if you're not sure about how to actually go about the question, always use the data that they've given. There'll normally be something that you can do, even if you don't necessarily know why you need to do it at this stage. So, using the data in the question, we've got a concentration and we have a volume for the sodium carbonate solution. So we can work out the number of moles that we have of sodium carbonate. So remember, our equation is N equals concentration times volume, but we have to convert our volume in centimetres cubed to a volume in decimeters cubed, because concentration is in moles per decimeter cubed. And to do that, we're going to divide by 1,000. So the moles of it are the 0.4 times 25 divided by 1,000, and that gives us 0.01 moles. Now we need to use the mole ratios. So we need to write our equation out. So we're going to write the HCl plus Na2CO3. This is an acid plus a carbonate. Remember, the general formula for this kind of acid-base reaction here is that we have a salt-forming CO2 and water. So we're going to form sodium chloride, NaCl, plus CO2 and plus H2O. And the final thing we have to do is just balance it up. So our sodium carbonate is formed from 2 sodium cations, so we have to put a 2 in front of the NaCl. And now we have 2 chlorines on the right-hand side, so we need to balance it up with 2 chlorines on the left-hand side, and then everything else balances. And by balancing this equation, what we've learnt is that 1 mole of sodium carbonate reacts with 2 moles of HCl. So the number of moles of HCl we have is twice the amount we calculated for sodium carbonate. It's 0.02 moles. So now we have the mole of HCl, we also have the concentration of HCl. Therefore, we can work out what volume we need. We need to rearrange our equation. I'm going to use the general form of this equation, that it's concentration times volume divided by 1,000. If we rearrange to find the volume, we need to times both sides of that equation by 1,000, and we need to divide both sides by the concentration. And this gives us that our volume is equal to the moles times 1,000 divided by the concentration. Again, the reason that 1,000 is in there is just to convert the numbers between decimeters and centimeters, because the volume that we're going to get out of here is going to be in centimeters cubed. So the calculation, therefore, is the moles 0.02 times 1,000 divided by the concentration, which is 1.5, and this gives an answer of 13.3 centimeters cubed. Again, as we saw in the previous video, you have to be careful with our significant figures. We can only ever give it to the minimum number of significant figures that we have in the question. Both concentrations are to 3 significant figures. Our volume of the sodium carbonate was given to 4 significant figures, so the minimum is 3, so we give our answer to 3 significant figures, 13.3. So, time to have a go at some questions for yourself. If you'd like to have a go, pause the video and the answers will be on the next slide. And so we have some questions here to do with calculating the moles in solution. So the first question was asking what the molecular relative molecular mass for copper sulfate is. If you remember from the last video, to calculate the relative molecular mass, we take the sum of all the relative atomic masses of all the elements that are involved in our formula. So we have the relative atomic mass for copper, 63.5, plus the relative atomic mass for sulfur, 32.1, and then plus the relative atomic mass for the 4 oxygens, which is 4 times 16. Remember that we always give our atomic masses to 1 decimal place. And this gives, when we add all that together, a molecular mass of 159.6. And here I'm using the term molar mass, so I'm putting the unit of grams per mole. You could just write it as 159.6. But remember that it is always to 1 decimal place. Then the question was to say how many moles there were in 4.32 grams. So this is a solid moles calculation. So we're going to use the equation that moles is mass divided by mR. And so when we do this, we have 4.32 divided by 159.6. And this gives our answer of 0.0271 moles. Remember, the unit for moles is just mol. And again, note the significant figures. We have 4 significant figures for the molar mass, 3 significant figures for the mass, and therefore we have to give our answer of moles to 3 significant figures. And then finally, we're asked to find out what was the concentration if we had that amount of copper sulfate dissolved in 250 centimeters cubed of water. And the way to do this is to use our N equals CV equation. We're going to rearrange for concentration, so we're going to divide both sides by the volume. And we have to remember, of course, that we have to convert our centimeters cubed and our decimeters cubed. So we've been given our volume in centimeters cubed, but remember that concentrations are given in moles per decimeter cubed. So in order to do this, we have to have our 1,000 in there. So it's moles times 1,000 divided by the volume is the concentration. And when we put all those numbers in, 0.0271 times 1,000 divided by 250, it gives an answer of 0.108 moles per decimeter cubed. So thank you for watching this video. I hope you found this video useful. You can find lots more like it on my YouTube channel. If you have found it helpful, please consider leaving a review on one of the tuition websites. I offer online tuition for chemistry. Please check my tuition pages for prices and how to contact me. And if you need any more help with your chemistry, you can always feel free to drop me an email. I'll be happy to help.